Hi guys, I hope you had a great weekend. So today we're going to talk about a relation versus a function. A relation is a set of ordered pairs. So we're talking about those XY coordinates that you can graph on a coordinate plane. But in order for it to be a function, then that relation, none of the X values can repeat. So a function is a relation where the X values do not repeat. Okay. It doesn't matter about the Y values. The Y values can repeat all they want, but the X values cannot. Okay. So we're going to go through a couple of examples here. For each ordered pair, we're going to fill in the mapping and the table. We're going to graph each point, and then we're going to figure out if it's a function or a relation. Okay. So if we just look at this, and we'll come back to answer the question about function or relation. If we look at this, we want to look at the X values. Okay. And we want to take all these X values and put them in order from least to greatest. So in this case, -2, -1, 0, 1, 2, 3, 4. They're already in order. So I'm going to write these on the left side of my mapping. This is my X values. And yeah. There are my X values. So I'm going to write these on here: -2, -1, 0, 1, 2, 3, 4. And then on this side are my Y values. Okay, so for my Y values, I'm going to, again, those need to go in order from least to greatest. So they're kind of out of order if we look over here. So we're going to start with the lowest value first, and that's -10. So -10, then -7, then -1, because that's the next lowest value, and then 2, 4, 5, and 8. Okay. And then the last step on a mapping is we're going to draw a line, a little arrow from the X value to its corresponding Y value. Now you did this in 8th grade. This is something that you learned back then, or you were taught back then. So the 0 is going to go down here to the 4. The 1 is going to go to the -1. The 2 is going to go to the 2. 3 to 5, and 4 to 8. Now, ideally, all of my Y values would have stayed in the oval. But, you know, Ms. Johnson doesn't always write very small, okay? So now let's put these points into the table. Again, we're just going to write our X values. It doesn't matter what order they're in, but we do need to keep the point values together. So the -2 is going to stay with the -10. So -2, -10, -1, -7, 0, 4, 1, -1, 2, 2, 3, 5, and 4, 8. Okay. All right. Now you guys know this is the part that's going to be hard for Miss Johnson. We're going to try and graph this thing. Okay. We're going to try and graph these at -2 and -10. Remember this, the X values go left and right, and the Y values go up and down. So, I have an extra dot that showed up. Let's erase that. And I'm not sure what happened. There we go. Hey, let's erase this extra dot here. All right. And let's go back to our color. -2 down to -10. This is where we're going to put our dot. Okay. And then -1, -7, we're going to put a dot here. And 0, 4, we're going to put a dot right here. And that one's about to disappear. All right. That's supposed to be a dot. All right. At 1, -1, we're going to put a dot. And, okay. At 2, 2, okay. At 3, 5, and at 4, 8. Okay. So there is our relation. Now, in order to decide if it is a function or not, okay, we can look at any one of these representations, okay, for the ordered pairs and for the table. If any of the x values repeat, it's not a function. Okay, ordered pairs and table. Not a function. If x values repeat. Okay, for the mapping, it is not a function if an x value has more than one arrow. All right. And then for the graph, it's not a function if it doesn't pass the vertical line test. Okay. Hope y'all remember the vertical line test. That's the one where you literally draw a vertical line, and if it hits more than one point, it's not a function. Oh, I did something wrong here. What did I do? Oh, I hit highlighter. That's what happened if the x value has more than one arrow. Okay, and then a graph, not a function. If it does not pass the vertical line test. All right. So take a look at the set of coordinate pairs that we have here. Okay. If we look at our x values, none of these repeat. None of our mapping x values have more than one arrow. They all only have one. None of our x values repeat in the table. And if I were to draw a vertical line anywhere on my graph, let's see how vertical I can get. Okay. If I were to draw a vertical line anywhere on my graph, I'm only going to hit 1 point. Okay. Granted, I can't draw a very straight vertical line, but you know what? Let's try this. I can draw a vertical line, guys. Watch. I'm going to insert a line. Wrong shape. I want a line. All right. So if I were to take a line and put it anywhere on my graph, let's make it a thicker one. Okay. If I were to take this line and move it anywhere, wrong one. I were to take this line and move it anywhere on my graph, it's not going to hit any more than 1 point. So there's 1, that's only 1, 1, 1, 1, and 1. Okay? So that vertical line test comes in handy. Okay? All right. I'm going to move this down so we can use it later. I'm going to move it down here so we can use it on our next one. Maybe. Oops. My vertical line doesn't want to go to the next page with us, guys. All right, here we go. Okay, let me make it vertical again. There we go. All right, we'll use that again here in just a moment. Okay, let's look at this relation. Okay, so I've got, you know what, we didn't make our decision on the last one, did we? This is a function because none of the x values repeat. It is a function. All right, now let's go back here. Okay. I have -4, -2, 0, -2, -4, -6, and -8 for my x values. Now, if I have a number that does repeat, whether it's an x or y, on the mapping, I'm only going to write it once. I don't need to write it more than that. Okay, so let's see. My smallest x value is -8. Then I have a -6, then a -4, a -2, a 0, another -2, and another -4. So least to greatest, these are my x values. And my y values, from least to greatest, I have a -8, a -5, a 1, 2, 4, 7, and 10. Okay? So now I have a -4 that goes to the 10. I have a -2 that goes to the 7. 0 goes to 4. -2 goes to 1. Oh, that one disappeared. A -4 that goes to 2. A -6 that goes to -5. And a -8 that goes to -8. Okay? Okay? On our table, again, we're just rewriting the points. We're just rewriting the points into the table. -2 and 7, 0 and 4, -2 and 1, -4 and 2, -6, -5, -8, -8. Okay? All right. Let me fix my 6 there. All right. -6. Okay. And then we need to graph it. So -4 and 10 is way up here. -2 and 7. 0 and 4. -2 and 1. -4 and 2. -6 and -5. And -8 and -8. Okay, so there's our mapping. Our mapping, our table, and our graph. And now if we take our vertical line, let me make sure it's vertical first. Okay. La-di-da. Okay. Yeah. It's about as vertical as I'm going to get it right now. If we take this and travel it along, well, look, there it actually hits 2 points. Same here. So there's 2 places along the graph where our vertical line hits 2 points. Okay, because of that, our vertical line, our relation here is just a relation. Whoops. It is not a function. Let me change thickness here. We'll go back to that one. Okay, it is just a relation. Okay. Also, if we take a look here at our mapping, 4 has 2 arrows coming off of it, and so does -2. So that was another clue that we have a relation and not a function. Okay. Let's take a look at our this table here. There are certain features about relations and functions that we want to make sure to remember. Okay. Both relations and functions always have a set of ordered pairs. X values can have more than one Y value, sometimes with a relation, but never with a function. Passes the vertical line test. Sometimes a relation will pass a vertical line test, but a function always will pass a vertical line test. Okay. Can it have a specific rule or set of rules to find more points? Sometimes. Sometimes a function or a relation will have a specific rule to find a set of points. Okay. And a function always will. Okay. Now, it may have a set of rules, for a certain set of X values, we're going to use one rule, and for another set of X values, we're going to use a different rule. But there will always be a specific rule to get from an X value to the Y value it needs to pair with. Okay? So, and another thing to keep in mind, if you think of it this way, you have relations, okay? Relations are kind of every set of ordered pairs. But functions are only a small set of relations, okay? So just because it's a relation doesn't mean it's a function, but a function will always be a relation, okay? So, all right, guys, at this time you need to work on your assignment packet. In the blue assignment packet, the pages 1 and 2, you've got some relations that you're going to be graphing, mapping, and putting into a table, and then you're going to tell me if it's a function or a relation. I will see y'all tomorrow. Have a great day, guys.